Y is inversely proportional to the square root of x. What that means is if I plotted y against the square root of x, then I would expect to get an inverse proportion graph. What it actually also means is if I was to plot y against 1 over root x, just flip it around, then I would get a directly proportional graph. And what we say is that y is directly proportional to 1 over root x. So inversely proportional to square root of x is the same as directly proportional to 1 over the square root of x. Now, what do we then do? We say that y equals k over root x because it's kind of following y equals mx plus c, but c is 0, and I just get this k as the gradient essentially. That's what you do, it's your constant of proportionality. So we've set up the equation, we just don't know what k is. All right, but we do know some values, so let's substitute them in. We know that 7 equals k over root 25, and that's equal to 5, so I can times through and I'm going to get 35. Not quite there yet, so now I've got that y is equal to 35 over root x. That's my main equation that I have. Find the value of y when x is 100. I just need to substitute in 100, so y is 35 over root 100, and that's going to be 10, so it's going to be 35 divided by 10, which is 3.5. That's the answer. So often you get answers such as 28 for this, but that's not the case because it's inversely proportional. If it was directly proportional to x, that would be the case. I would quadruple x, so I'd quadruple y. But it's inversely proportional, but it's also inversely proportional to the square root of x. So you need to have this kind of working in there. And I've talked a bit about the graphs to kind of generate the understanding, I hope. And this is how you do it. This is the answer.